Assalamualaikum warahmatullahi wabarakatuh. Today our group will present about the auditory system in sport. Okay. For that, my name is AKMAL bin HAMDAN. What is auditory system? Basically, in the simple word of auditory system, we call the system that is responsible for the sense of hearing. That is we call the sound or the volume that we hear before into the send the impulse to the brain, and we call the auditory system. Okay, in the auditory system there are two subsystems. There is peripheral auditory system and central auditory system. For peripheral auditory system, they have include the outer ear, middle ear, and the inner ear. For the central auditory system, they have from the cochlear nucleus up to the primary auditory cortex. Okay, so in sport, the auditory system is function for the teammate. As example, the communication between the teammate to achieve the sport goals. So they will communicate. Okay, the sound of the communication that the teammate hear, it will before send the action, before they do the action, it will process at the brain. So from that, they must throw into the auditory system before they get the impulse. Okay. So for next is this is the example of the pathway of the sound, how the sound get into the brain. The first one, the sound will enter to the outer ear at the pinna. The volume, the wave of the sound will enter the outer ear at the pinna. After that, they pass along the ear canal to the eardrum. Wave to the eardrum, and at the eardrum, the sound will wave to make a wave and make a vibration. At the eardrum, they will connect with three tiny bones, that is ossicle. At the vibration that process the making from the bones at the eardrum, it will pass along these three bones. So the vibration from the eardrum, you will pass at the three bone that is from the ossicle. The third three bone, that is the last bone, is the stapes. The stapes will process again the oval window to the cochlea. Here, the pressure will the vibration will go into the cochlea. Okay, so the vibration pass into the fluid inside the cochlea. After they arrive at the cochlea, they will pass with the fluid. At there, they will shake 1,000 of tiny hair that stick into the fluid from the hair cell. As the hair vibrate, the hair cell generates nerve signal before sent to the brain. The nerve signal travel along the auditory nerve to the hearing center of the brain. If the signal is produced there at the canal before sent to the brain. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is ZAHAR. Okay, I will present about motor control. Okay, motor control is a broad term that describe the general ability of a person to initiate and direct muscle function and voluntary movement. Okay, next is meaning to say, it's more like a concept that is distinct from many involuntary muscle action in body. For example, shivering when cold, or flinching when an object is direct at a person without warning. Meaning to say, flinching is more like nervous. The person will nervous when they will face a sudden test, so they will nervous. Okay. In other words, a related expression which is motor skill refer to the ability to perform specific physical movement. Also the equation and for development of series of distinct of motor skill. Okay, motor skill consists of two. First is fine motor control, and the second one is gross motor control. Okay, I will explain gross motor control first. Okay, gross motor control is like a First is gross motor control. My name is AZMINA. For gross motor control, it's like the ability of humans to move a large muscle group or segment of anatomy. Okay, for example, the waving of arm is an example of this type for motor control. For meaning to say, it use a large muscle group for the human to move. Okay, the second one is fine motor control. Okay, for fine motor control, is ability to manipulate precise movement such as handwriting. All the motor control is a integrated product of three aspects in human anatomy. It is a muscle, bone, and the central nervous system. Okay, next is this is movement generating circuits. Okay, first it start with motor cortex. Then it will go to the motor neurons. Next is a effector. So after that, they will go to the self-generate sounds. So after go to self-generate sound, it will go to the sensory organ. Meaning to say, sensory organ will appear, the suitable organ will have a sensory about the sound. Same goes to external sound. It also go to the sensory organ. Then they go to sensory neurons. After that, it auditory cortex. That's all from me.
Okay, first of all, Bismillahirrahmanirrahim. Okay, my name is Mohamad. So my part is I want to present to you, all of you, about the what we call anatomy of the auditory system. Where is your auditory system? Here, your ears. Okay, we call it auditory system. Okay, which is the division that we separate the outer area. First of all, outer area. Second, middle ear, inner ear, and last we call it as central auditory nervous system. Okay, first of all, outer area. Okay, we can see this is we call outer area. So outer area that we can see and we can visualize from okay. Second is middle area, which is we conclude the malleus, incus, and stapes. And lastly is eustachian tube. And third division we call it as inner ear, that consists of vestibular, semicircular canals, and cochlea. And lastly is central auditory nervous system, which is consists of nerve, which is facial nerve, cochlear nerve, and internal auditory canal. Alright. Okay. Next we go to the mode of the each operation, each division. Okay. First of all, we go to the outer area. Outer area mode of operation is air vibration, which is first process is we enter the audio and we conclude as air vibration. Next is middle ear. Middle ear mode of the operation is we call it mechanical vibration, because it will work the malleus, incus, and stapes, which is in the middle ear. It will happen the mechanical vibration after the air vibration from outer area. Okay, next is inner ear. Inner ear consists of mechanical operation, hydrodynamic, and electrochemical. You get the audio and you transfer process, and in the inner ear it will give the electrochemical that work the semicular canal, vestibule, and so on, and cochlea. Alright. Lastly is central auditory, which is includes of mode of operation is electrochemical. It will see your reflect for the nerve. Okay. For the function, outer area function. Okay, function outer area. It will protection, amplification, and localization. Second, middle ear consists of impedance matching and pressure equalization. From outside you enter, it will cause the pressure on your middle ear. Okay, third is function filtering distribution, which is you filter. Filter the okay. The audio will enter the filter. You will filtering first before you send to the central. The audio sent to the central auditory. Okay, last is central auditory nervous system. The function is lastly information processing, which is from here, and lastly you will get into the central auditory. It will cause the information processing. So that's all from me. Have a nice day. Okay, next is middle ear. Middle ear mode of the operation is we call it mechanical.
So I will continue about the auditory system and motor control. Okay, we explain about the structure of the auditory system. Okay, this is the example of the structure of the auditory system that divide into three parts, which is the outer area, middle area, and inner area. Okay, first we go to the outer area. Okay, for the first, the outer area. Okay, we focus on the pinna. Pinna is the part of the area which is surround of the area, the outer area, which is the function of the pinna is the sound reflector. Means the pinna helps the brain to give the direction to the brain, which is where the sound is come from, which is from the left, right, or other position, which is the pinna help to identify the direction of the sound, then give the instruction to the brain. Okay, next is the middle ear. Okay, for the middle ear is we focus on the eardrum. Okay, when the sound wave hit the eardrum, it will convert into the FV cavity, which is the information of the sound, and the sound vibration will hit the eardrum and give the high pressure and to send the information to the brain, and the vibration that come from the eardrum will enter the oval window. Okay. Next, the last part is the inner area. Okay. The inner area. This part is the ear is filled with the liquid more than the air. Okay. The main structure of the inner area is the cornea, where the wave is transformed into the neural form, which is the cornea is transferred the waveform transformed into the neural form. Okay. The last information is the auditory nerve, which is the parts of the hearing combined with the vestibular nerve. Vestibular nerve is which is the balance of the sound, forming the cranial nerve, or the scientific name is the vestibulocochlear nerve. Okay, that's all from me. Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Okay, today I'm going to talk about describe the physiology on how auditory system contributes to motor control. Okay, the impact of music and sound on motor behavior is multifaceted. First, football players adjust team members to fans' acclamation. They respond to acoustical atmosphere within the arena, and they react to the rhythm and the essence of the referee whistles. Okay, next. Sport gymnasts and dancers synchronize their movement to accompanying music or arrange certain elements related to the melody individually, together with a partner or within an ensemble. Okay, next. Runners synchronize the step cadence to perceive music and even pace themselves over a race by arranging a special sequence of different music pieces with varying tempo for tuning their running speed over the course. Okay, music can be used to modulate the heart rate, the perceived excitation, or the general arousal, as well as the basic activation of these brain regions. Okay. In most of these correlation between music and motor behavior perception, higher cognitive functions are broadly involved. Music is audible only after auditory stimuli are processed by a widespread cortical network. However, a more direct sensory-based impact of sound on motor behavior occurs as acoustic information from earlier stages of auditory processing is integrated into motor control. Natural motion attendant sounds are used for controlling and optimizing motor behavior. The performance of a tennis player decreases if auditory perception is obtruded. And similar findings have been reported on table tennis. Synchronization in team rowing is partially realized by analyzing sound of the boat and of the swivels. In a diversity of sport, the all-around sense of hearing direct the specially restricted visual attention. For instance, in team sport, the orientation of guests is partially affected by surrounding sounds induced by the step of teammates or opponent. Auditory input affect gaze behavior as well as orientation behavior fundamentally straight on the sensory level when integrated with visual and proprioceptive input in the collicalized superiors. These structures located in the brainstem are on the other hand emitting motor efferents, which are directly specified by a special formation of the current multisensory input. The multisensory motor characteristic of the collicalized superiors has been studied intensely by Perry Stang and Alex Meredith. This region can be understood as an outstanding example for a straight but flexible responding sensory motor interface. It indicates how seamlessly multisensory information is merged together already on the subcortical level and even down to the level of a single neuron. A multisensory convergence neuron integrate auditory, visual and proprioceptive input, and the same neuron respond with descending motor output. Okay, thank you.